Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over radioactive decay and half-life. So let's get into this. So in previous videos I've talked about radioactive decay and the different kinds of radioactive decay, and let's just remind ourselves what causes radioactive decay, and that is that the atoms are too big. You have too many protons, right? So remember, the protons are positive. You got all these positive protons in the nucleus. They want to repel each other, but what's holding them together is this nuclear strong force. And so that strong force acts over really tiny distances. So the protons are close to each other, and you also have neutrons in the nucleus as well. So you got these protons and neutrons that are really close to each other, and that's adding to the nuclear strong force. Well, if you have too many neutrons, or maybe even too few neutrons, this will make the atom unstable. The nucleus of the atom will be unstable, and therefore it will undergo certain kinds of decay in order to change that neutron to proton ratio, right? So again, if it's too small, it'll undergo some sort of decays. If it's too large, if you got too many neutrons, it'll undergo decays to try to lower the amount of neutrons and try to increase the number of protons. If you've got too few neutrons and too many protons, then it's going to it's likely to undergo those sorts of decays that are going to increase the number of protons decrease the number of protons and increase the number of neutrons. So that's why atoms undergo radioactive decay. But radioactive elements also have different stabilities, right? So, and because they have different stabilities, this is going to lead to different rates of decay. And so this gets us to this idea of a half-life. So the half-life is a measure of how quickly something's going to decay. And so here's the definition of a half-life. So it's the length of time that it takes for half, hence half-life, in order for half or 50% of your original sample that you started with to undergo radioactive decay. Basically, what that's saying is half of your sample is going to be gone. Now, that doesn't mean it just disappears into thin air. What's actually happening, and as we saw in radioactive decays, is that your element is changing into a different element. So maybe you have uranium, and your uranium decays into lead. So it doesn't mean that the uranium atoms just disappear and you get less substance. It's just that that substance is being replaced by something else like lead, right? But the original sample, the original element you have, the amount of it is cut in half after one half-life. So again, so it's the length of time. The half-life is the length of time it takes for basically half of your original sample to become something else, to degrade into something else. So you only have half of it left after that time. So different materials are going to have different half-lives. So for example, carbon 14 has a half-life of approximately 5,730 years. What that means is if I start with a certain amount of carbon 14, after the half-life, or after 5,730 years, I will only have half of it left, right? But uranium 235, or is it 238? One of those two has a half-life of 4.5 billion years, right? So if I start with the same amount of carbon 14 as I do with uranium 238, in order for half of it to disappear, my carbon only takes 5,730 years. So after that amount of time, I'll have half of it left. But in that same amount of time, I'll barely lose any of my uranium because the half-life is much, much longer than that of carbon 14. So here's a quick example of what we're talking about here with regard to half-life. So let's say I have carbon 14, and again, the half-life is 5,730 years. And let's say I start with 20 grams of this substance, which is going to be the same as 100%. So whatever my starting sample is, that's the 100%. So I'm starting with 100% of my sample, which is 20 grams. And then fractionally, we could call that 1. So I'm starting with a ratio of 1. Okay, so here, if I undergo 1 half-life, which means after 5,730 years, now my 20 grams of carbon-14 is down to 10 grams. So the other 10 grams has decayed into something else, but I have 10 grams of my carbon-14 left. That's 50%. So I'm cutting it in half. So I cut the grams in half. I'm cutting the percentage in half, and I'm cutting this in half, so that becomes 1/2. So I have half my sample left. After another half-life, so that's another 5,730 years, that's going to go by. So that's going to be a total of like 11,000 and something years or more. So here, another half-life goes by. I cut that sample in half. So I'm going from 10 to 5. So now I have half of that sample that's left. So that's another half-life. And now I have 1/4 or 25% left of my original sample. So 5 grams is 25% of the original 20. So that's 25% of the original 100, or 1/4 of the original 1 that I started with. So I divided in half here to get from 100, to get from 20 to 10, 100% to 50%, or 1 to a half. And then I divide by half again to go from 10 to 5, or 50 to 25, or 1/2 to 1/4. So that's 2 half-lives. What about a third half-life? If I undergo another half-life, so another 5,730 years go by from this point, my 5 grams that I have here becomes 2.5. It divided in half again. So my 25% becomes 12.5% left, and my 1/4 becomes 1/8 left. So I have 1/8 or 12.5% left of my original sample that I started back here, 20 grams. And again, this can go on and on. So another half-life, another 5,730 years go by. So this is my 1, 2, 3, my 4th half-life. And so now my 2.5 grams becomes 1.25 grams from the original 20 I started with. That's going to be 6.25% left. So I go from 12.5, divide that by 2, I get 6.25% left, which means the same thing with my fractional amount. So if I have 1/8 here, divide that by 2, I get 1/16. So I have 1/16 left of my original 1 that I started here. So this is a good example of what we're talking about when we're talking about the half-life and how much of a substance is left after a certain number of half-lives go by. I hope this video was helpful. If you enjoyed this video, if you learned from this video, please make sure you hit that like button, and also subscribe to my channel and hit that notification bell so you'll be notified by other videos I put out. And put a comment down below in the comment section. Let me know what you think, or if you have any questions or comments for me. Thanks for joining me, and have a great day.